Causal models and linear models live in different realms. And I remind you the separation in three demons. I developed this idea of the three demons to illustrate the importance of understanding the models that we have, what are they trying to achieve. So the reality demon tells us about models that are about reality. So these are mechanical models, computational models, and some mathematical, but the quintessential models that are reality, models about reality, are computational and mechanical. So the models try to mimic what the reality does. The second type of models are what the models that a causality demon would develop. These are more abstract models, but they are models about reality. The abstraction is that a mechanism that would have a mechanical model will be simplified into variables. And so it is a model about reality, but it will be more abstract than a direct model of reality. The model of reality is also an abstraction, because if we use a mechanical model to describe reality or try to predict what happens in reality, is still an abstraction. So we are talking about reality demon and causality demon. We're talking about models about reality with different levels of abstraction. The probability demon deals with numbers. So the models that the probability demon will develop have nothing to do with reality. They are models about numbers. And that's what is very, very important, because it's missed in most research in psychology. Researchers develop models that the probability demon would develop, statistical models. The linear model that we've seen and all its versions, the t-test, ANOVA, and regression, or other types of linear models. And these are the only models they do about in their research, and they put the model, the statistical model that the probability demon would develop, as a model of reality. And that's very problematic, because we think about what fits the mathematical model rather than thinking about reality and try to understand reality. That's why it's so important that we first develop a causal model and then a statistical model that will help us understand reality. But it's not a model about reality. So, causality demon and probability demon. We are not going to develop models about reality, direct models about reality, or models with less abstraction. We are going to go to the abstraction of the causality models, or causal models. The linear models are not models about reality. So why do we have to use both, causal models and the linear models? Well, because they belong to different realms. So in terms of causal models, I'm going to in this masterclass, I'm going to use an example that comes from my research. And here we've got the causal model and the linear model. So the causal model that we are going to go through is practice affects performance. So we've got two variables. One is called practice, the other one is performance. And the linear model that will help us understand reality, but it's not a model about reality, is the one that we've seen in other classes. Y equals beta 0 plus beta 1 times x plus epsilon, which stands for error, where error is considered a random variable that is normally distributed with a mean of 0 and a standard deviation sigma. Now, the same model, but a different way of expressing it, is that y is a random variable that is normally distributed with a mean of gamma and a standard deviation of sigma. And gamma equals beta 0 plus beta 1 times x. And in order to make it specific, so that's the generic form, and we make it specific and we say that y equals performance and x equals practice. So one thing that is important, in the causal model you've got the causal variable practice and the performance variable, and the consequence variable performance, and you have in the linear model you've got sort of inverted. So you've got the causal variable on the left and the consequence variable on the right. Now the variable in the linear model y, you've got it on the left, and the causal variable x, you've got it on the right. So this is very important. Don't get confused in this respect. Now I'm going to use this model to explain the aspects of causal models and aspects of the how do we compute the linear model.